Sin. A sin that is most of us guilty of, especially when we started with Angular, and that sin is called function calls in a template. I will show you lots of code examples, but you can find everything in a GitHub repository under the name Krivanek06, example projects, and the folder Angular memo, because like there are lots of folders. So we will talk about the good, the bad, and the ugly side of using function calls in a template. However, I would argue that even if you are an experienced Angular developer, then I believe you can still learn something from this presentation because we will take a look at how we can still use function calls in a template with a little bit of trick. Okay, so something about me. I work as an Angular developer at Bitovi. It is a consultancy company. My interest lies in tech, finance, and Web3 applications, but I haven't built anything yet, but it just seems cool. And I just like destroy so many Angular applications so that I know what I should not do. Okay, that's the promo about me. So what we are going to build? We are going to build the next $1 billion company where we can search for some anime content and display that data in the table. Fair enough. Okay, so what we have? We have some search component, we have some table header component, and also the table body where we display some data. So far, so cool. However, with a little bit of caveat, and that is that the custom field that is inside the table, that red number, is calculated, and it is calculated with some equation where we have to plug in the item score that we select, and by the score we will end up with some number. And that is interesting though. Like if you are wondering like what this equation actually means, then I have to tell you then it means absolutely nothing. I just need an example to demonstrate the following problems. Okay, moving on. So the table of content, we will first talk about how most of us like used to solve this problem and how still like junior developers solve this problem by function calls in a template. And we will talk about why this may not be the most appropriate approach. Then how right now most of us would solve this problem by introducing pipes. However, we will take a look at why pipes even work. You know, what happens that if you build an application, then what is the generated source code that allows pipe to not uh, trigger the method, this transfer method that is inside the pipe for every changed action. You know, what's behind of that. And if we learn this secret what pipes has, then we will be able to create some of our own function that is called memoization. Okay, so how most of us like used to solve this problem back in the days is just creating a function in the component class and calling this function in the template. And what you can see that it actually works, like there is nothing wrong with this, or is there? For some reason, seems like that every time when I click on the button or I type something to the form, then I can see this console log being triggered in the development environment. So that actually means that my equation is being reevaluated again and again whenever there is some user event. Okay, that's interesting though. So the question is, why is this even happening? This is happening because of the Angular, how change detection works in Angular. Change detection is, I guess you might know, responsible of figuring out which part of the UI needs to be changed. And once Angular figure out like, okay, you should probably these components are dirty, so some value might have changed. Please check yourself. Then when the components like check whether the old state is different than the new state, there is a small problem with that. They just cannot remember the value that has been already computed with a function that we are calling in our template. So every time the components performs that change detection, it just has to reevaluate again and again that function what we are calling in a template, simply meaning that whatever logic is inside the function, it will be just recomputed again and again, which is maybe not necessarily what we want. The problem starts to be like if we are using more than one component in our application, which is usually the case. So in this example, we have like two siblings components, two of the same sibling components, and both of them are using this function call in a template. And what you might see that even if I trigger some user event in one component or the another component, both sibling functions are evaluated again and again, which might over time, if you have like 50, 100, or even more function calls in a template, it can really slow down your application. So why is this happening, you might be asking? So this is a picture I shamelessly stole from one of the YouTube creator. This is happening because if you have a component tree and down in the line you have some button which actually doesn't do anything, and however, if even if you are click on that button, then Angular by its parents will propagate a user event to the application reference where zone.js, that is a library responsible to detect which part of the UI or which component might be dirty, which one should uh, check themselves. So that button component will issue a user event to the application reference, and Zone.js will create a tick event and basically mark every component that is inside our application as dirty if you are using the change detection default strategy, which is usual case, and we will talk about it. What is the second one? Second one. So by that, it actually seems like that whatever user event happens throughout our application, whenever, for some reason, Angular still marks every component in our application as dirty, and they just have to check the old state with the new state. Usually, this process is quite fast. You even if you might be using like 50, 100 function calls in a template, you will not see a significant slowdown of your application at the beginning because like usually we developers have our oldest M1 Max Pro, right? But also because Angular does this very efficiently. So once you start to see some of the performance slowdowns by function calls in a template, then you know you are in a really big trouble. Okay, I mean, you might be saying right now, I know, I will be using change detection strategy on push because every Bible, every documentation says that if you want to be a top G in Angular, like you have to use change detection strategy on push. That's the way and follow my path. I'm like, okay, I mean, I'm gonna use it. And if you read the documentation how this on push change detection strategy works, then you will find that the component will perform a change detection, so comparing its old state with the new one in four cases. First one is that if the reference to the input property changed, or if we have our custom event emitter and we emit some data to the parent component, or we manually call the detect changes, or we use the async pipe. So actually, only the first three rules are applied. Async pipe is will not trigger change detection. Actually, the implement inside the implementation of the async pipe, there is that detect changes function call. Okay, so let's have the same example that we have like two sibling components and we mark that same components as change detection strategy. So basically none of these four cases are happening. So basically my component should not be marked as dirty and Angular should not perform change detection on my component because it marks as on push and none of those four cases are met. However, what you will see that if I selected one item in like both components, when I create some user event, then I can still see that function being evaluated in the template. And that's interesting. Like none of these four cases have been met. Why is this happening? What Angular fails to mention is that even if you are using on push change detection strategy on your component, and you will issue a user event, so typing to the form, clicking to the button, then that component will still propagate a user event to the application reference component, where Angular will mark every component that lies on the branch where that child component issued this user event. So every sibling component that you have in your application, which are marked as on push, and those four criteria are not met, then that component will not be dirty, and it doesn't have to check its old value with the new one. However, every component that's on the tree has to perform change detection on any user event. But the question is like, is this a problem, right? So let's run some performance test. What we will see that if we use our math equation for example, for 1,000 items, it takes only 34 milliseconds to evaluate this equation for 1,000 items, which is usually never a case. Like most of the times we display around 100 or 200 items in our application, like not 1,000 one. So even if there are like four user events per second, and four times per second this change detection is triggered on the specific component, it will still take only roughly around 50 milliseconds to evaluate this equation. So, then is it cool to use function calls or is it not? Let's take a look at this example. So let's say we have five of the same components displayed, where each of them is marked as change detection strategy default. On each component, we display around 10 to 15 data, and we perform like 10 or 15 user events per 5 seconds. By 5 seconds. And what we will see that from those 5 seconds, when the components were marked as change strategy default, we spent only around 163 milliseconds of actual time focusing on that function call in a template. And what if I mark every component as on push? What will be the performance increase in this case? So once again, the same example, five components, every component's 10 to 15 items. I create some user event, typing to the form, clicking to the button. And once everything is done, what I will see is a big significant improvement is that from those 5 seconds, I spent only around 36 milliseconds of evaluating this function call in my template. And this significant improvement is because once you used change detection strategy on push, then Angular only checked those components which lives on the branch where the child component issued this custom event. It didn't have to check all those sibling components. So basically, even if you are using function calls in a template, uh, the saying goes that if you mark your components as change detection strategy on push, you can immediately see a significant improvement or performance of your application. But of course, if you are using on push, you cannot mutate your object, so you cannot have something like object dot key equals whatever. You have to use spread syntax to, if you want to mutate your object, to always create a new instance of that object. However, I'm running on the latest M1 Max Pro, M1 Max, whatever. So you might have worse results, and the end user who has like really old computer might have even worse results. So why should I care? You might be asking. You should care because you might have a use case where you don't have only just one equation that has to be computed, but you might call functions in a template where you have to loop, for example, throughout an array which has 1,000 items, filter them, map them, reduce them to some single result, and display the data in a template, which that operation can take much more time that my simple mathematical equation. Also, you might have an example that you are using a function call in a template which creates a HTTP request to your server side. And you know that function calls from this presentation are triggered every time when there is any kind of user event inside that component on that or that component branch. So when you have this example, what might end up happening that you will issue a bunch of HTTP requests to your server. And in this case, we are not using any kind of caching, so we are issuing a bunch of HTTP requests to our server, and you might accidentally DDoS your server side, which you probably don't want to be the responsible person. Okay, so how most of us would solve this problem is just basically copying the logic what we had in our functions into the pipe. And we know that pipes are the logic inside the pipe, inside that transfer method, is only computed if the arguments what we pass to the pipe changed. So yeah, this is kind of an example how most of us would solve this problem. And this actually works. Like most of us would stop here, and every time when I select an item I want to display in the table, then one HTTP request has been issued per item, and I don't do any kind of caching. And okay, like you might be asking yourself, like, all right, I know this. Like why should I listen to? I know this. I knew this before Angular were even introduced. I'm like, okay, hold on. Like, but do you know why? Like, what's happening behind the scenes that we can use pipes in a template, but we cannot use function calls? Like, what's the magic behind that? I'm glad you're asking. So let's take a look at this component. Like, what will happen if we run the ng build command? We will end up with like a bunch of nonsense where if we clear that nonsense out, we will have this part which represents our war component template. And this is this example pipe component where our component is called the same. So here we will see this template function, which consists of two parts like ref and one, ref and two. I don't know what is it, but here in this ref1, I can see that there is some h2 element, there is the button inside the div, and there is this click event listener. Okay, so seems like in this first section is my HTML declaration, what I can see in the template. And when you read the Angular documentation, you will see that this rf stands for renderer flag. And this first section runs when we create our component, and this second section runs when we want to update our component. Okay, but we want to take a look at this example pipe component underscore div whatever section, which is responsible for rendering the block inside this ng for loop to display each row of the table. And by the way, if you want to read more about all of these element and start, text, whatever syntax, then you can visit the view data markdown file inside the package core source renderer tree. It's a good read. Okay, so let's take a look at this table body part, but that what you can see right now in the picture. And you will see that here we have some kind of pipe declaration. We have our or instantiation. We have our async pipe and hard map equation pipe. Okay. And under the update section, we have some kind of text interpolation. So I guess it will take the result of the pipe and just display them in the template. Maybe, who knows? And but we are interested in this pipe bind one function. Okay, it's interesting. Like what it does, why it's called pipe bind one. I don't know. Let's take a look at that. So here is that. What we will see that at the first three lines we are getting some information from our pipes instance. I mean, cool. I don't know what's going on. After that, we check whether the pipe is pure. So we can set our pipe as pure, true, or false. By default, every pipe is pure. However, seems like that from this function, if we set our pipe as false, then for every update method, so every time our component has to update itself, so for every change detection, we can say if the pipe is marked as pure equals false, then it will run this transform method that is inside our pipe. So just seems like that if we mark the pipe as pure equals false, then it will behave exactly the same as we would use a function call in a template. Okay, but the pipe is pure. So in this case, pipe is pure, and we will run this pure pipe function internal function. What it does, it just creates some kind of index. I don't know what it is. And then it will check this binding update function. And based on that, whether it returns a false statement, seems like when this binding update returns a false statement, we will just get the already computed value for our arguments that was computed by the pipe and just return that value. Or if not, then we will run this update bindings method, which I guess will take our currently passed arguments and run the logic that is inside the pipe. So what this binding update function actually do? So seems like it gets the old value. So in our case, this old and the new value, old value and the value are just arguments that we pass to our pipe. And if these arguments, if the old arguments and the new arguments are the same, it will result, it will return a false statement, and it will just return the already computed value that we provided, already computed value that our transform method did. So, okay, so seems like that for every change detection, this pure function internal is running, and for every change detection, it just checks whether the old value, old arguments that we provided to the pipe are different than the new arguments. If they are not, then it will just return the cached result that the pipe already computed. Okay, okay, interesting. Man, you might be wondering like, what do I do right now? It was interesting to check the generated code, but like, what can I do with that? I'm glad you asked. What if you can actually take this knowledge of checking the old value that we provide to our function calls in a template with the new value and somehow make it run only if the new value has changed? So let's take a look at two examples, or I guess three examples. One of them is creating a purifying pipe. I'm apologizing. I found this example somewhere in the GitHub long ago, but I wasn't able to find it again, so I cannot put the URL here. But what is happening though that in this fn.apply method, we are getting a reference to the function that we want to run in the template, and we just applying the arguments. So we will end up with something like this. So instead of manually calling our function in the template, we will delegate this responsibility to this purify pipe. So our pipe will call our function in a template and apply arguments to that. And what's the difference? The difference is that we know that if we use pipe, this transform method will not run again and again if the arguments to the pipe don't change. And if we use this syntax, we know that probably our functional template will never change. However, only the data can. But if the data don't change and that we pass to the purify pipe, then it has no reason to perform this transform logic. And that's cool. Like you can see here in the example that first of all, I have a normal function call in my template, and I select the item, and every time when there is a user event, I can see that console log on the side. However, if I use this purify function, and I will do the same example of selecting one item like multiple times or creating any kind of user event, then the logic that is inside the function used in the template will not be triggered multiple times. And how it works actually, if you are using this purifying pipe, then you have to provide some arguments to this pipe. Otherwise, it will not work if you just apply this pure pipe to some functions. You have to provide some arguments into that. Otherwise, it will not be working. I mean, cool. I think you are thinking about that. That's, I mean, so cool. Let's take a look at another example. Like, let's talk a little bit about dynamic programming and memoization. So, what is in the hell memoization? Memoization stands for storing the result of an expensive function call and returning the cached result when the same input value occurs. I mean, cool, cool. So how exactly it works? Seems like we can use this memo function to wrap any kind of function because it expects a function as a parameter. Seems like it creates some cache lookup object where the key is some kind of string and the value is unknown. So the value can be string number, object, or observable. It stringifies the arguments that we pass to the function. So we can pass number, string, object, whatever, and it just checks whether the data or the arguments that we provide to the function are already in that cache. If not, then it will just run the logic of the function that we provided to this wrapper function and then just return the value from the cache. Okay, looks interesting. So what we can do with this logic is just take it and wrap it around the decorator. So all, all what this logic actually does, it just creates a decorator that we can use to our functions inside the component. And we will end up with this one. Like we have a function call function that we want to use in template, and we are using this custom memoized decorator. And every time when I select the same item multiple times, what I will see that the logic inside the function that is highlighted with that yellow is run only once, and whatever user event happens, I'm just reading the value from the cache. Exactly how pipes work. They again, for every update, they are just comparing the old value with the new one, and if it not changed, then they just return that from the cache. This is exactly what we do. However, this is just not working if you are using a function call in a template that returns an observable. So here in the same example, it actually will work, but with a little bit of caveat, and that is every time when you select an item, I hope you can see that, even if it's the same item, you issue a HTTP request to the server. So basically it works exactly the same as pipes works. However, we don't want to do that. We just want to create one HTTP request per unique item, not for the same item. So here we have our custom memoized decorator. And what we know that when we apply for when we apply our arguments for the on this original method, it will return an observable for this case that if we use a function call in a template that will create a HTTP request, then this calculation will be an observable, and we are storing an observable into this cache lookup and returning an observable, and we have to subscribe to the observable, and that's why this HTTP request is issued again and again, and no caching is implemented yet. So if we know that, then seems like we can trigger this calculation as an observable and save the value a little bit a different way. So what we can do that if this original method indeed returns an observable, then we can just apply the pipe function and the tap operator and save and after the successful HTTP request, save the result into this cache lookup. And if we put the same arguments or the same data to our function call in the template, it will just return the value that is already cached. And the end result, what we achieve is the following. So we have our function call in the template and using the async pipe. And here is our function call, and we are applying this custom Memoize observable to that. Okay, and the end result, what we will achieve is that if we select the same item multiple times, then only one HTTP request per item will be issued to the server side, and that can be seen on the network tab. And this is kind of cool. So basically, with its custom Memoize observable, you can not just still use function calls in a template, but you can use function calls in a template that creates a HTTP request to your server, and it will create one HTTP request per unique item. Sounds interesting to me. And if you are wondering, like, you probably will never have this case, but what if? What if you want to implement a caching mechanism on your pipe level, not on your service level? So you can achieve that. You have to create a static property on your pipe level, and it has to be static because if you have a for loop and you are using a pipe inside a for loop, then it will create a new instance every time, and you want to share that logic between instances. So you will create a static cache property, and once again, just check whether the data is already in the cache, and if not, then create a HTTP request and save that value to the cache. And by the way, I guess you already realize I'm a big Naruto fan. So yeah, as we talked about at the beginning, like signals are coming to the Angular ecosystem. Like right now, it's very questionable what will be like the significant improvement that signals brings. We already can experiment with signals from the Angular 16.0 version, I believe. And what I know so far, the signals will be responsible of, so signals will completely get rid of zone.js, and it will just mark the components that has to be rendered, like which, not the whole tree or the whole application, but only components that something changed in them. Only those will like check whether the old state changed with the new one and re-render them. So I think maybe it's safe to argue that if once signals will be introduced and it will be a common thing to use, maybe we still, once again, will be able to use function calls in a template because Angular will know which part of the application or which component change, so it doesn't have to render everything else. And maybe, just maybe, pipes might be deprecated. Who knows what lies in the future? So some key takeaways from this presentation, like if possible, then avoid using function calls in a template. It creates like really slow performance and it's a real bad architecture. If possible, then create a pipes per logic that you have to use in a function because it's once again a great architecture and everybody knows how pipes work. And if this is not an option, if you were assigned to the project where there are like 100 function calls in the template, the project is very slow and you want to earn your quarterly bonuses, then consider using change detection strategy on push and use this custom Memoize decorator or this purifying pipe to your function calls in a template. So basically that's everything from me. I hope you enjoyed this presentation. I hope you were able to take something from that. And if you want to reach out to me, you can reach out to me on eduardkrionek.com or any social media, and hope to see you next time. Maybe question if there is any.
Hi. Thank you so much for the session. It's been quite amazing. I like your slides, by the way.
Thank you. I did this theme on some Halloween presentation, and I was like, nah, it's fine. It will be fine.
Yeah, they look pretty amazing.
Thank you.
So anyone with a question?
Hmm?
Uh, you can just unmute yourself, Dedan, and ask.
Hi guys, thank you Edward for the good presentation. So please could you share the slides for our perusal?
Yeah, sure. I cannot type here, but I I will I will email to the Angular Kenya team and give the link to my slides.
Alright, sounds good. Thank you. Thank you.
Yeah,
Thank you. Sounds good.
I have a couple of questions.
sure.
Um, so you said that when we're creating our own custom pipes, we can say whether they should be pure or not, right?
That's right.
So my understanding of pipes is we need to maintain them as pure because the idea I have about pipes is whatever input we're giving them, we need to predict the output. So if you set a custom pipe as impure, will the maintenance cost not be high?
Honestly, I never came across a scenario where you would use pipes as impure. So setting the pure equals false. In
Mm-hmm.
this case, they would behave exactly as a function call in a template, and I don't know honestly, like why is there that option or what are the use cases where you would have to use that. I personally never had to do that.
Okay. Um, my other question would be, you said memoization is a strategy in dynamic programming, right?
Yeah, I had this fancy memo. Where is it? Wait. Here is it. So yeah, like memoization is just storing some computation and returning that computation for the same input value. Memoization is used for uh, in interview questions or in like CS, like some CS question, for example, if you have to create a palindrome,
Yeah,
then
yeah.
you can use memoization for or dynamic programming for that.
So doesn't it affect your by you storing data in a cache? How does it affect the performance of your application?
Yes, so let's take a look at this example. Like if you create this decorator and you apply to the function in a component class that you will use in a template, then basically you will allocate some memory to store the computation into that cache lookup and just returning the value for the same input. And however, if you navigate away from that component from that page, so this component is destroyed, then all the data that was in this cache will be destroyed again. So it's not like a permanent global storage, but it's a storage on the components level. Not sure
So that so the
if this
cache is
yeah.
so say I go to the app which you're on right now and search for Naruto, and then I I, I cancel my session on that site, so the cache is cleared. So the cache will be cleared at that time.
Yeah. So if the component, if this cache is used on two siblings component
Mm-hmm.
and you create two instances of this cache memory, so they don't share the data, and you destroy one component, then that cache will still live on that second component's instance. But if you navigate back and you create the first component once again, then this cache will be empty. So you all once again have to compute this data. But I think this is how pipes also work, because like if you navigate away from the component where you are using pipes, you navigate back, then that logic that is inside the pipes still has to be evaluated again, because you create a new instance of a pipe in that page.
Yeah, that's how pipes work. Yeah.
I guess you can like introduce NGRX or some kind of global state if you want, but this is like a really good and a fast way, I would say, to increase the performance of your application. It's not the recommended way though. Like if you are gonna use this and like your team or you have some junior developer who will see this in the first time and it will leave your company, go somewhere else, then like I don't know how it will turn out.
Okay, thanks for. I have one last question.
Sure.
There's this slide where you're saying to avoid making multiple calls to the HTTP causes the DDoS errors.
Yeah.
No, the top one. This is
Which one?
this one. Yes, this one.
Okay.
So could you go to the code which improves this error? I mean, which gets rid of this error, DDoS error.
So if you don't want to use this Memoize decorator in this example, then you have to copy this code to a pipe. So yeah, like that, like create a pipe and put the code here and just use the pipe in the template as most of us used to. Like don't do this. Like in animes, like don't do it. Like my computer crashed when I did that. So I just wanted to demonstrate. Probably nobody will do this, but I just wanted to have like a hardcore example that this can happen, and I wanted to include this meme. So that was my reasons.
So for me, what I do, I don't know whether it's right or wrong. When I'm making requests to an API or something, I use the bounce time from time to time. I don't know whether that's right or wrong. To avoid making multiple calls to the API or something of that sort.
Well, what are the examples? Like you are using debounce downs on some form
Yes,
value change.
yes, yes. Say someone is searching for a movie in my site or for an artist in my site, and I'm using an API from somewhere. So uh, I give, I use the bounce time so that after a period of time is when I make a call to that API.
Yeah, I think this is usual a case how we also do it in my company, that we yeah, like in my case, like I'm searching for some content that I want to display in the table. So once again, this like searching for some content and I want to display them in the table, I would apply debounce time like I don't know 400 or whatever, and this thing until change and create a HTTP request.
Okay, okay. I think my questions, I think no more questions. Thank you.
Yeah, sure.
Yeah, it was quite an
I
interesting
think,
session.
Yeah,
sorry.
I'm glad you like that.
I think mine is just to add on to the Joy's uh, comment on the bounce time. Like I think it's not a bad thing to like use the bounce time, and especially when it comes to like forms or even at the same time. Still, like when you are doing such, right? It's usually also a bit prudent to also use the bounce time because you don't want to be making um multiple calls and after every keystroke, because that doesn't really make sense, because that's a lot of API calls. And then again, of course, when it comes to billing by the end of the month, you have so many API calls, for example, to your backend or wherever you've hosted your database. So I mostly use the bounce time and switch map. That means that it makes sure that everything is complete before it's just to the next one. So that's I think that's not a bad thing. Yeah.
Do you
Mm.
guys know the famous interview question like higher order observables, like the difference between switch map, concat map, exhaust map, and merge map? What those are?
Would you
I
like to
just know
tell us?
switch map is.
I got you right.
Yeah,
I don't. I've never had an interview question like that. When have you?
I
I've read those interview questions.
Uh,
I had that one, and I also used to ask people this one because like once the people know that, then you can assume that that person is like more skilled in Angular, or maybe like name some pipes. What are those pipe operators that you would use? So you would expect something like buffer array or something more advanced than like first or debounce down. Like just curious what people use.
you said paper operators.
Yeah, pipe operators like not just like map filter, but all those higher order observables and something like buffer array or uh, I don't know, nothing else comes to my mind, but just something more unique what people don't usually use on a daily basis.
Okay, because I haven't used the thing you mentioned in buffer array. Yeah. So Wayne, do you have a question? Does anyone have a question?
I think I'm good. You've actually asked most of the questions that I was thinking of. Yeah.
Yeah. So thank you so much. We're waiting for you in Kenya for our next physical meetup.
Yeah, it was awesome to be here. Thanks for the invitation.
Yeah. So yeah, thank you. It was quite interesting. I've